So by using this equation, that is a determinant, we can find out the moment by any force about the given point. So we will use this formula to find out the moment for given system. So just I will show the moment, how to calculate the moment by a single force. So here we have one force at the point A. So the coordinate for the point O, as it is the origin, so it is 0, 0, 0. For the point A at which the force is acting, its coordinate will be point A is exactly along the x direction. So its x coordinate is 6 meter. Its y coordinate is 0 because it is on the x axis, and therefore z coordinate is also 0. Okay. Now here the position vector will be, so this is the position vector which is R OA. Okay. So this position vector we can find out. This is equal to, as ROA, that means it is 0 minus 6. So this is the force which is a 5 kilonewton and it's acting at the point 600. And this is the point about which we want to take the moment. So this is the point O, coordinate is 0, 0, 0. So its position vector will be directed like this. From point O to A. So this position vector is R bar O to A. Okay. So this position vector we can find out as, this is your x1 value, sorry. This is x2 value, so x2 minus x1. So it is 6 minus 0 into I plus 0 minus 0 and plus 0k. So position vector is Ri plus, sorry, 6I plus 0j plus 0k. So this is Rx, this is Ry, and this is Rz. Okay, so you can consider this point A at which force is acting as a point x1, y1, z1. Moment point as x2, y2, z2, and then this is x1 minus x2, y1 minus y2, and z1 minus z2. So now put this value in this equation. So this is moment by the force F2 about the point O. So this is equal to, this is Ijk. Position vector Rx is 6, then 0, 0. Now refer the force vector. Okay, so force vector F2, this is F2 bar is equal to minus 5g. So Fx is 0, Fy is minus 5, Fz is 0. Okay. Now solve this determinant. So you will get the answer as minus 30k. So this is only for the force F2. Similarly, you have to find out the moment by individual force F3, F4, and F5. So I will just write the value. You try to solve this by using this method of determinant. So moment by F3 about the O, this is equal to 30I minus 36K. Moment by F4, this is equal to minus 10I plus 8K. And moment by F5, this is equal to 35I. Okay, so the Varignan's theorem is summation of moment by all the forces about O. This is equal to moment by resultant about the point. Now here we have assumed the resultant at this point. This is the R, this is X, and this is Z. So coordinate of the point M, this is X, 0, and Z. Okay. So this will be the position vector. This is the point O. This is Y, X, and this is Z. This is 0, 0, 0. This is the R bar. This point is M, having the coordinate X, 0, and Z. This is the moment point O, having the coordinate 0, 0, 0. Now assume this is X1, Y1, Z1, and this is X2, Y2, Z2. So position vector, this is the position vector, which is R, OA bar. Okay. Sorry, OM bar. So for the moment by resultant, this is I, J, and K. So position vector Rx will be X minus 0. So this is X. So it is X, 0, and Z. And the force vector, which is Fx, this is 0. Fz is 0 because the resultant is along the Y direction. Its J value, so this is minus 19. Okay, so refer the resultant. J is minus 19. So this is the moment by resultant. So you can solve this. So you will get the vector 19Z into unit vector I minus 19X into unit vector K. So put this value here. Okay, equate these two values. Summation of moment means we have to add all the values F1, F2, F3, F4, and F5 on. And after equating left hand side and the right hand side, you will get the value for X. This is equal to 3.05 meter, and the Z value, this is 2.89 meter. So from this equation, you have to equate the coefficients on the left hand side and on the right hand side. Okay. So finally, you will get this answer, X and Z. Okay, and this is the third type of system. So now we have seen the concurrent force system, parallel force system, and this is third type, which is the general force system. So formula for resultant is same for all the systems. So we will use the basic formula, which is R bar is the vector addition. F1 bar, F2 bar, F3 bar, so on. So now for the given system, there is one cube and there are total 5 forces acting on the cube. So their directions are given. Okay, we have to write the force in the vector form and then we have to find out the resultant. So question is we have to find out the resultant for the given general force system. So for that, first write the force in the vector form. So I will write F1 bar is equal to mod F1 into unit vector in the direction of F1. So observe the F1 in the given diagram. So this is the F1. Okay. So F1 force is directed from the point A to the point E. So its unit vector will be unit vector AE. So this will give the direction of that force. And the magnitude of the F1. So F1 is given as a 1 kilonewton. So you can write the magnitude of all forces. So these are the magnitude for F1, F2, F3, F4 and F5. Then F2 bar, this is equal to mod F2 into unit vector. So F2, it is directed from point F to the point D. So this will be unit vector FD. F3 bar, this is equal to, so force F3. So this is the force F3 from point G to the point C. So unit vector GC. F4 mod F4 into unit vector. So this is the F4 starting from A to the point G. So unit vector AG and F5. So F5, it is parallel to y-axis. So we can directly write the value as its magnitude is 2 into unit vector along the y direction. So it is J, and it is negative because directed towards negative y direction. So this is F5. Now for remaining forces F1, F2, F3 and F4, we have to find out these unit vectors. Okay. So for the unit vectors, we have to first find out the coordinates. So I think coordinates are directly given. Okay. So you can find out the unit vector by using this formula. This x2 minus x1 I, y2 minus y1 into j plus z2 minus z1 into k upon the magnitude. So find out unit vector AE, unit vector FD, GC and AG. Okay. Put the value in these equations. Get the value of F1 bar, F2 bar, F3 bar, F4 bar, and finally use this formula to find out the resultant. Okay. For your reference, I will give the answer for resultant. You can verify your answer. So this resultant, it is 1.56 I. So the resultant R bar, this is equal to 1.56 I minus 0.2 J minus 0.45 K. Okay. So verify this answer whether you get the same vector or not.